In this video, I'm going to continue discussing some of Python's functional style programming capabilities, specifically filtering, mapping, and reducing. Now, in prior videos and prior lessons, we've introduced each of these capabilities. So, for example, over the last couple of videos before this one, we talked about things like list comprehensions and generator expressions, and specifically in the context of list comprehensions, we introduced filtering and mapping. Filtering to look at a sequence of values and include in the result only those values that matched some condition that we specified, and mapping to take each element of a sequence and produce a new sequence with the same number of elements, but each value mapped to a new value, which, by the way, does not always have to be the same type. It can be a completely different type, and we did demonstrate that as well. Now, we've also previously looked at reductions, such as the sum function that's built into the Python language, which is capable of taking a sequence of values and reducing it down to the total of those values. And we'd like to revisit all of those concepts here in this video. Now, the focus of this video is primarily going to be on filtering and mapping. Filter and map are functions that are built into Python, and they're examples of so-called higher order functions. That is, they are functions that can receive as arguments other functions that help them perform their tasks. In the case of filter, we're going to give it not only a sequence of elements that we want to filter, but also a function that specifies the condition that each element needs to satisfy in order to be included in the result. And in the case of map, we'll give it a sequence of items we want to map, as well as a function that will perform the mapping operation and give us back the new objects that should be included in the resulting sequence of elements. Now, as you're going to see here, functions in Python are objects. Because they're objects, we can do things like assign them to variables and use them at a later time. We can pass them to other functions for execution, and we can also return them from functions as well. Functions are basically data just like integers and floating point numbers and strings and any other type that you process in Python. Now, as you'll also see in this video, there are two different ways that you can pass around functions in Python. One is via the names of existing functions, and the other is by creating functions inline where they're needed via a keyword called lambda that we'll introduce in this video as well. So with that said, I'm going to switch over to a terminal window, and to help with saving some time as I present this particular example, we're going to go ahead and define a list called numbers for the purpose of this example or series of examples that I'm going to present to you. Now, the first thing I want to take a look at is a filtering operation where we're going to produce a new list of elements that contains only the odd elements in this particular collection. So let's define a function for that purpose. I'm going to copy and paste it here. And as you can see, we have a function called isOdd. You give it an element, and it's going to tell you whether or not that element is an odd value. So we're going to divide the element by 2. We're going to then check to see if the remainder is equal to 0 or not. If it's equal to 0, it would be even. If it's not equal to 0, which would be true in this case, it would be odd. So anything that is odd will result in this function returning a true value. So let me go ahead and define that function. And let me copy in another statement here that's going to create a list using the results of the filter function. Now, the filter function is lazy. It does not perform a task until you iterate over its results, and the list function is actually going to do that iteration. It will iterate over the results of its argument and give me back a list containing those results. So let me execute this first, and then let's talk about the arguments to the filter function. So you can see here we get only the odd values from our original list up above. Now, as you can see here, filter takes two arguments. The first is the name of a function that's going to return true or false, and the second is the sequence of elements that we would like to process. In this case, the list called numbers, but any iterable sequence of elements will work in this context. Now, what's going to happen is the filter function will take every element in the sequence, and one at a time will pass it to the isOdd function. The isOdd function will then obtain a value of true or false, and filter based on that value will decide whether or not to include the element in the resulting sequence of values. Then the list function will take that sequence of values and turn it into a list object in this case. Now, everything that you're seeing here is equivalent to the following list comprehension. So this is a little bit more verbose, but let's take a look at it because it is kind of the preferred way of creating lists with filtering capabilities in Python. So we have this list comprehension once again, and the for part helps us determine what we're going to iterate over. So we have for item in numbers, so for every one of these numbers we're going to pick off one item at a time, and if that item is odd, we will take that item and include it in this list that is being created by the comprehension. So you can see that the comprehension produces the exact same set of results here. Now, in this brief example so far, I pre-created an isOdd function for the purpose of this demonstration, but you don't have to actually do that for simple functions like this. You can actually define them in line right where you need them. So let's take a look at our very first lambda expression in the context of Python. Now, some of you have probably used lambda expressions in other programming languages. In Python, lambda expressions always begin with the lambda keyword, followed by a parameter list specifying the names of the parameters that will be used in the body of the function that gets generated for you as a result of this lambda expression. The parameter list is always followed by a colon, and then the body of a lambda expression in the context of Python can literally be only an expression. You cannot put a whole bunch of statements in the body of a lambda as you can in some other programming languages. For example, in Java, we have both expression-based lambdas and statement lambdas, where you can have as many statements in the body of a lambda as you would like. So in Python, lambdas are always going to be pretty simple and straightforward. In this case, implicitly, the lambda is going to return the result of this expression, which is going to take whatever value we give it, divide it by 2 and get the remainder, and again, if that remainder is not equal to 0, that would mean we want to include that result in the sequence of elements that filter produces. Filter is going to apply that lambda expression to every individual item in the numbers sequence, and again, filter is lazy until you actually iterate over the results, which we're doing via the list function call, but you could also do, for example, in a for loop. Until you actually iterate over those results, filter does not execute anything. It just gives you back an iterable object that you can then iterate over. When you pass an iterable object to the list function, it in turn creates a corresponding list. Next, let's continue by discussing the map function in Python. So again, this is built right into the language, so you can simply use this function. First, let's just list out the numbers in our collection once again, and let's use a similar expression to what we did up here with filter to actually map each of the elements to the squares of those elements. So let me go ahead and paste in the statement that we're about to execute. So once again, we're going to create a list with the results, and just like filter, map is a lazy function. It returns an iterator, not the actual sequence of elements. You then have to use that iterator to iterate over the elements and do something with them. When you pass the iterator to list, it automatically iterates over the sequence of values and produces a list. If you use the map expression, or the map call rather, in a for loop, then each iteration of the loop will get the next element from the mapped sequence. Now in this map call, we're going to be processing the elements of numbers once again, and here is the lambda expression that we would like to apply to every element in the sequence. For the element which we're going to call x, we would like to take x and square its value. So this lambda expression, rather than returning true or false, is going to return the square of its argument. And by the way, lambda expressions can have multiple parameters. You would separate those with a comma, just as you do in a normal parameter list. So let's execute this, and you can see we get the same number of elements that we had in the original numbers sequence, but in this case each of those values is now squared. Now of course, in addition to doing this with map, you can do this with a list comprehension. So for example, here is the equivalent list comprehension, and you can see that for every item in the sequence numbers, we would like to include in the resulting list the squared value of that item, and indeed it does produce the same results. Now, one of the other things that we demonstrated to you in the context of list comprehensions was the fact that you could mix together the concepts of mapping and filtering into the same list comprehension, and of course you can mix together those things as well using the filter and map capabilities. So here we have a relatively complex statement compared to the things we've looked at up above, which consists of creating a list from the results of the nested operation here. The nested operation is a mapping operation in which we are going to square every element of the sequence produced by this call to filter. So let's start with the filter call here. In this case, we have the filter call, which is going to look at every element and check whether it's odd. If it is odd in the numbers sequence, we will include that in the results produced by the iterator that filter returns. That iterator is passed as the second argument to map as the sequence of values that we would like to map. So whatever those odd values are, we would like to map them to those values squared, and then that map function returns an iterator which we pass to list, and list iterates over those results to produce the final list of values. So there is our mapped sequence, our mapped and filtered sequence of values. Filter first, then map. And of course, as we've shown you up above, that can also be done with a list comprehension, which in this case is much more concise than the snippet 9 code up above here. So again, for every element x in the sequence numbers, if that element is not divisible by 2, meaning it's odd, if that element is odd, we would like to include in the resulting list the square of that element. And again, we can produce that result. So far we've focused here on filtering and mapping, and I just want to reiterate this issue of reduction we've started to talk about by showing you built-in functions such as sum, or by taking a look at some of the functions built into the statistics module like mean, median, and mode in a prior lesson. Those are reductions that take a sequence of values and turn them into a single value. You also have the ability to use techniques like what I've shown you here in this video, such as lambdas, along with a function called reduce that is part of the func_tools module. So I just wanted to pull up the online documentation here. We're looking at the Python library documentation for the func_tools module, and you've seen how to import modules in prior examples and lessons, but I specifically want to find on this page the reduce function so that you can see there is a function for creating your own custom reductions, and they have a description of that function here along with some sample code as well. So for example, this particular lambda that they've shown here is going to iterate through the list 1 through 5, and for every pair of elements it's going to add them together, and that produces this calculation. So what it does is it takes x and y as initially the values 1 and 2, and then from that point forward it takes the sum of the preceding operation and adds it to the next item in the sequence. So you start with 1 and 2, 1 plus 2 becomes x in the next expression, and at that point the y is going to be the next item in sequence. So 1 plus 2 is 3, then we add 3 to that to get 6. 6 is now x in the next expression, which does 6 plus 4, which gives us 10, and then 10 becomes x in the next expression, which gives us 10 plus 5, or 15, as the total. And you'll notice there's an optional initializer argument. So for example, if you were doing the product of all the values, instead of plus here you would do times, and maybe you want to start with the value 1. Of course that happens to be the first value in this sequence, but if you were doing a sequence that didn't start with 1, you might want to begin with the value 1, or you may have some more complex reduction that you'd like to implement, and let's say you were starting with or starting to reduce a bunch of strings into a single string. Maybe you have a header that you want at the beginning of that string, so maybe that string object is your initializer, and then everything else gets tacked on to the end of that. So I would encourage you to experiment with the reduce function and trying it out with both lambdas as well as named functions, just so you can get a sense of how it works.